When I hear of research talking about dust in the universe, I get very excited because it's a fascinating topic. Dust is not only in the molecular clouds that form stars, but also shields them from the intense radiation around them that will destroy them, and then we wouldn't have stars. Also, dust is found in the debris disk that is left after the star is formed, and likely the seeds for planet formation. Here on Earth, dust is responsible for the formation of clouds, and we have heard so many times that we are made of stardust. So, who doesn't like dust? However, the study of dust is complex, not only understanding its composition and how it forms, but also how it can survive the most extreme events in the universe, like the one that we are going to cover here. Recent observations of a beautiful spiral galaxy called NGC 6946, made with the James Webb telescope, looks to investigate how much dust is produced by two supernova type 2p, which are likely the result of the rapid collapse of massive stars, which after exploding remain bright with a constant luminosity for an extended period of time of at least 100 days after their maximum. That's what made them deserve the letter P in the name, because the light stayed in a plateau for a long time. So what we are looking for dust in the remnant of a supernova, where we know that dust is produced in the ejected material of evolved stars that are low mass, and it takes a long time for reaching this stage, which is much longer than the age of the distant galaxies that we observe. So dust cannot be formed that way there. So how it is formed? Well, using JWST, we can investigate this problem because dust emits in the infrared the light that JWST can observe, and also JWST is very powerful and can resolve these envelopes around the supernova explosion, which help us pinpoint where the light comes from and also test this theory. The group of astronomers working on this problem look where most of the infrared luminosity was coming from and also its temperature. Knowing these two pieces of information helps them to determine if the dust was there before the explosion or was produced after the supernova exploded. The conclusion was that indeed the supernova produced this dust, and that the two supernova produced a total of half to 15 times the mass of Jupiter of dust. However, we can only see warm dust with the infrared light that JWST can observe, and there could be also large amounts of opaque dust that remains undetected. This will be observable as the ejecta continue to expand, and if further observations find that the supernova produced more than one solar mass of dust, then scientists might be able to explain the amount of dust that we observe in the early universe.